Hi, we are doing lesson 3.4, Isosceles and Equilateral Triangles. There's two objectives. The first one is how do we classify triangles and use the angle-sum theorem to solve problems, and two is how do we apply the isosceles triangle theorem and its inverse. So when it comes to triangles, we can classify them by sides, and also we're going to classify them by angles. First one, we are classifying by sides. There are three types of triangles. We have scalene, isosceles, and equilateral. For the first one, scalene, the sides are all different, so there's no congruent sides. With isosceles, there are two congruent sides, as you can see by the markings. And with equilateral, all the sides are congruent. So three congruent sides. When classifying triangles by angles, there are three types of triangles based on angles. We got acute triangle, obtuse, and right triangle. With the acute triangle, all the three angles are acute. So as you can see in the diagram, we have one that's 40, 85, 55. It's all less than 90. With an obtuse triangle, there has to be at least one angle that is bigger than 90 but less than 180. In the diagram you see that this is 120, the vertex, and then the two sides are 30. And in a right triangle, there's going to be one angle that is 90 degrees. So as you see in the diagram, we have the 90 degrees and the other two is 60 and 30. Triangles with three congruent angles are called equiangular. So equi means equal and angular, angle. So when it comes to the angle-sum theorem, it states that the sum of the interior angles of a triangle is 180. This is something you already know. You know triangle, when you add up all the angles, it's all 180. So with the example below, it says use the angle-sum theorem and angle pairs to find the missing angle measures. So you already learned about the angle pair. If we look at it, you notice that the two lines are intersecting to create vertical angles. So what we learned about vertical angles is that they're opposite and they're going to be congruent. So I'm going to put the two markings to show that these two angles, angle 1 and angle 2, are congruent. So angle 1 is congruent to angle, oops, I don't know why it's being all wonky, angle 2. So now we need to find the missing angles, 1, 2, and 3. I'm going to actually highlight the different triangles. So we have this triangle, I'm going to call it the green triangle, and the other one will be the blue triangle. So that way we can distinguish the two. So I'm going to start off with the green triangle. Actually, no, I'm going to start off with the blue triangle because it has 2 out of the 3 angles. So you got these two, and you know that a triangle is 180, so you can find the third angle, which is number 1. So we're going to have 43 plus 74 plus, I'm going to put x for angle 1 equals 180. So this is for the first blue triangle. So when you add up 43 and 74, you're going to get 117 plus x, and then you subtract that by you subtract it from 180, and you will have x equals 63 degrees. So that angle over here is 63 degrees. So based on what we know about vertical angles, we know that they're congruent. So that means angle 2 will also be 63 degrees. And now you'll be able to find angle 3 because we have at least 2 in order to find the third. So again, you're going to add 63, 79 plus, and I'm just going to use y because we already used x, and equal it to 180. So when you add those two, you should get 142 plus y, and then you're going to subtract that from 180. So that will give us 38 degrees. So this will be 38 degrees. So we found angle 1 to be 63, angle 2 is 63, and angle 2 is 63, and angle 3 is 38 degrees. So that is using the angle sum theorem. Alright, let's go on to the next. The next one is the exterior angle sum theorem. So it states, let me go to the select. It states that the sum of the remote interior angles is always equal to the exterior angles. So I'm going to draw a picture so that way you understand what they are talking about. So imagine, actually I'm going to use the shape, and I'll just use this triangle, and then I'm going to extend the line, the bottom, the base. Alright, good. So now, when they talk about the remote interior angles, they're talking about this angle and this angle. So I'm just going to color it in. So those are the remote interior angles. So remote interior angles. Okay, and now it says that it's always equal to the exterior angle, and that I'm going to use blue. So exterior angle. So this is the exterior angle that they're talking about. So the sum of the remote interior angles is always equal to the exterior angle. So when you add these two up, whatever value they give you, it will equal this exterior angle on the outside of that triangle. Alright. So we're going to do an example based on that exterior angle sum theorem. So they want us to use what we know about special angle pairs and using the angle sum theorem and also the exterior angle sum theorem to solve these two problems. So the first one, it has 50 degrees and then it has 65 degrees on the interior, and they want us to find angle 1. So this one we're going to be using the exterior angle sum theorem. So we add the two, so it'll be 50 plus 65, which will give us angle 1. So when you add up those two, you will get 115 degrees for angle 1. So this will be 115 degrees. That's all you have to do. There's another way you can do it, but it'll take more steps. You could actually add up the two, subtract it from 180 to get this, and then subtract 180 from whatever number you got for this one to give you 115. But why do all those steps when you can just do one little work, which is add up the two remote interior angles and get your exterior angle? Alright, let's go on for the second one. They gave us two of the interior angles, use blue for this one, and they want us to find angle 1 and angle 2. So for this one, we're going to add up first to get the exterior angle, to get angle 1, so 35 plus 25. And I'm going to put, this will be for angle 1. So then when you add up those two, you're going to get 60 for angle 1. Oh, that was messed up. Let me undo that. 60, and I'll put degrees for that one, will equal angle 1. So this part is 60 degrees. Now they want us to find angle 2. In order to find angle 2, you know that angle 1 and 2, look what's going on. They have AC, segment AC, as their common segment. When you have those two angles put together, they create a line, which is 180. So that means they're linear pairs. So in order to, what you learn about linear pair is that if the line is equal up to 180, so the two angles have to add up to 180. So that means you're going to use 180 minus 60, and then you're going to get 120 for the second angle. And I'm going to do that and put 120. So if you were to add up all these numbers, you would get 180. And these two add up, gives you 180 to give you that linear pair. So that's using what you learned about the special angle pairs, angle sum theorem, and the exterior angle sum theorem all together. So they're all connected. All right, let's go on to the next. I'm going to expand this and use select. All right, so we're going to talk about isosceles triangles. The congruent side of an isosceles triangle are its legs. The third side is the base. The two congruent sides form the vertex angle. The other two angles are the base angles. So we're using this diagram, the legs, and I'm going to mark them based on the color that I'm going to use. First let me select. So the legs is XY and YZ. And I'm going to mark that in blue. And since this is an isosceles triangle, that means these two are going to be congruent. The base is XZ. And I'm going to make that green. So that way you know, you can see the connection. The vertex angle is angle Y, or you could also call it angle XYZ. And notice that the Y is in the middle between the two letters because it's the vertex. Anytime you're labeling an angle and you include the vertex is in the second position. So you can either say angle Y or angle XYZ. And for the base angles, basically it's the angles that are opposite the sides, the congruent sides. So we have angle Z, and then we have angle X, which I will label in red. Right. So you have all the parts of an isosceles triangle. You have the congruent legs, you have the congruent bases, and you have the base itself and the vertex. Right, so with that, we're going to talk about the isosceles triangle theorem. So it states, let me expand that, and I'm going to scroll down so it can be bigger. So it states that if two sides of a triangle are congruent, then the opposite angles are also congruent. And when you use symbols, based on the diagram that we had above, it says if XY is congruent to YZ, as you can see, which it is, then the opposite angles are also congruent. So that means angle X is congruent to angle Z, which is true. So that's the isosceles triangle theorem. All it's telling you that when you're dealing with an isosceles triangle, if the two sides are congruent, then the base angles are automatically congruent. So we're going to do an example based on that theorem. It says in the diagram below, they said that GH, so I'm going to mark the congruency, GH is congruent to HK, and then HJ is congruent to JK. So I use another color to distinguish that, and to make it easier to distinguish, I'm going to make this the blue triangle, and then the other one will be a green triangle. Oops, try that again. Undo, and then highlight. Oh, wrong one. Okay, so make that green and this side green. All right. So they said list the isosceles triangle. So knowing what we learned about isosceles triangle, if there's two congruent sides, right away we know that it's an isosceles triangle. So there's two of them, and of course you would list them as triangle with the symbol triangle, HJK, and triangle HGK. So those are the two triangles. If you don't put that symbol, then these letters could stand for anything. I could think that you're talking about angles. I might think you're talking about a plane. So that's why when you put those little symbols in front of your letters, it tells somebody that, okay, you're talking about this triangle. Or if there was an angle, you're talking about that angle. But since we're talking about triangles, make sure you put the symbols, because if not, it could mean anything. Now, the next one, they're asking us to find all the missing angles. So I'm going to start with the blue triangle. So I'll use the blue pen. This part here says 100. These two are congruent. The two legs are congruent. So that means this angle and this angle, the base angles, are going to be congruent. So let me expand. I'm going to expand the page. So with the first triangle, I know that the triangle has to be 180. So I'm going to put 100 plus the base angle. Since they're going to be the same, I'm going to double it. So 2x equals 180. Then I'm going to subtract 100 on both sides. That gives me 80. And then I divide 2. And then my x, which represents the base angle, will be 40 degrees. And I'm going to make this big, and then I'm going to fill that in here, 40 degrees. All right, so I'm done with the blue triangle. Now on to the green triangle. I don't have any angles for it, but all I know that GH and HK are congruent. So that means the base angle, G and K, are going to be congruent also. So how do I get started? Right, I have this angle that says 40. I know that when I have two angles butt up against each other and they create a line, the line is 180. So these are linear pair. So with linear pair, I can find the other angle by subtracting the 40 from 180. So I'm going to use, I'll use purple to do that calculation. So I have 180 minus 40, and that will give me 140 degrees. So go back to green. I'll make this 140. Now I can find the other two because I know these two angles will have to be the same. So going back to my calculation, I'm going to do 140 plus 2y. I'll use y for this one, since I used x for the other one, equals 180. And let me scroll. So then when I subtract, I get 2y equals 40. And then I'm going to divide 2 on both sides. And I'm going to get y equals 20 degrees. So this will be 20, and this will be 20. And if you add up all together, it will be 180. Same thing with this one. You add these two up, you get 180 for this blue triangle. And if you want to really make sure that you have all the numbers correct, if you add up all this angle together, this angle, and this angle, this, and that, so you get 20 plus 60 plus 100 plus 100 will give you 180. So everything works out well. Okay, so that's how you find missing angles based on what you know about isosceles triangle. Right. Now, we learned about the isosceles triangle theorem. Now we're going to do the converse of the isosceles triangle theorem. With the converse, it's nothing but the opposite of what was said for the isosceles triangle theorem. So it states that, if I can move that up here, that if two angles are congruent, then their opposite sides are also congruent. We learned that in the isosceles triangle theorem that if the opposite sides are congruent, then the two angles are congruent. So this one is just, they just swapped. So basically it's saying first that if the angles are congruent, the two angles are congruent, then the opposite sides are congruent. And using the symbol based on the diagram that we worked with in the beginning, if angle x is congruent to angle z, then xy, segment xy, is congruent to segment yz. All right, so for the example number 2, it says name the pair of congruent angles that is not already labeled. So we have some of the labeling. So we know that this whole triangle, I'm going to use green for that triangle. So this whole triangle is an isosceles triangle because of the marking. And then the little one, which I will use blue for, shows that triangle BFBC is also an isosceles, because look at the angles. They're congruent. So therefore that means the sides will be congruent. So we need to name a pair of congruent angles that is not already labeled. So if you look at it, I'm going to use the blue first. So looking at this triangle, two angles that are congruent, I would say these two, and also for the green triangle, I would mention that this and this, so angle ACH or ACF and AFC are congruent. So let me unveil the answer. So, and then we got angle BHF and BHC, which are congruent. And then we have BFA. Yeah, so BFA and BCA are congruent. So let me try to clean that up. Let me take this out and then this out. So these little angles, these two angles are congruent. Now they want us to name a pair of congruent sides that is not already labeled. So we're going to do the labeling first. So for the blue one, we're looking at congruent sides. We said that this is congruent. BC and BF are congruent because the base angles are congruent. And we also have, let's see if there's anything else that we're missing. Should I unveil that and see what I have? Yeah, so we have FH and AH. Oh my God, FH is congruent to HC. So that will be the green one. So the bottom part, this is congruent to this part. And let me make this bigger so you can clearly see what's going on. So again, we had this whole triangle. The two sides are congruent, so therefore this whole angle will be congruent. This small triangle, the blue one, is an isosceles triangle. The base angles are congruent, so the sides will be congruent, and so will half of its base. These two are going to be congruent. Alright, so all we did was just dealing with congruent sides, congruent angles based on the isosceles triangle theorem. Okay, and the last triangle, equilateral triangle. So basically, you know that equilateral triangle is also equiangular. That means all the angles are equal, or they're congruent, and all the angles of an equilateral triangle are, like I said, congruent. So the sides are congruent, the angles are congruent. So that we can use that information in order to do this example. It says that triangle EFG is an equilateral triangle. EH bisects angle E. Remember about bisecting? When you bisect an angle, it creates two congruent angles, and they want us to find measurement of angle 1, 2, and Y. So for the first thing I'm going to do, I'm going to mark that angle 1 and angle 2 are congruent. So I'll write that here. Angle 1 is congruent to angle 2 because EH is an angle bisector, and it bisects these two into two congruent angles. And we know that EFG is an equilateral triangle. That means all the sides are equal. So this side, and this side, I'll just mark that they're all congruent. So that means these angles have to be congruent. So the first thing we're going to do is, we know that it's an equilateral triangle. The angles are all congruent. The triangle is equal to 180. So if you have 180 and you got three angles, you divide it by 3 will give us 60 degrees. So this one will be 60, this will be 60, and that whole thing will be 60. And since this is being split up into two, it's being bisected, this will be 30 and this will be 30 to add up to 60. So now we know that this is 60 and 30. We know that this angle, I'm going to put that in purple, is going to be 90 degrees, because 90 plus 30 plus 60 gives us 180. So that's 90. So now we have this piece. Let me mark the angles that I already found. I found that angle 1 is 30 and angle 2 is also 30. So I got 2 already. And now for the y, we need to find the value of y. This says 15y degrees. We know that this has to equal 90. So when we do the work, we do 15y equals 90. And then you divide that by 15 and you will get 6 for y. And that's it. So we found both of the angles, 30, and then we found our y based on the information that was given to us. So again, when it comes to problems like that, read it first, then read it again to find out what they gave you, all the little clues, what they want you to find. And then use all that information and then solve, and then you get your answer. All right. So we are at the end of this lesson. And just as a recap, we learned about how triangles can be classified by sides and angle. 3 types of triangles: scalene, isosceles, equilateral. Equilateral means all congruent sides. Isosceles means 2 congruent sides. And scalene means none of the sides are congruent. They're all different. With angles, we have acute triangle. That means less than 90. Obtuse triangle, at least one obtuse angle that's bigger than 90, less than 180. And a right triangle, which is 90 degrees. And triangles with congruent angles are called equiangular. And we learned about the angle sum theorem. It states that all the angles has to add up to 180 in a triangle. And we also learned about the exterior angle sum theorem. The remote interior angles, as seen here, has to add up to give you the exterior angle on the outside. And it always equals that. And then we learned about isosceles triangle. We know it's 2 congruent sides. If there's 2 congruent sides, then the base angles have to be congruent. If the base angles are congruent, then their sides is congruent. And that's basically the isosceles triangle theorem and its converse. And we learn the properties of equilateral triangle. Triangle is also called equiangular. That means all the angles are congruent and the sides are also congruent. All right, so this ends our lesson, and see you next time.